Hello everyone, I'm João from That's Brilliant, and in this video we're going to continue doing the mathematical proofs of the derivatives of the trigonometric functions. So this is the fifth video. I'm going to put the link of the last videos in the description below, and the proofs are very similar, so I don't want to be very repetitive, so this video is going to be a little bit quicker because, as I said, the proofs are very similar. And I told you the same thing on the last two videos, and I ended up doing even longer videos. So in this video, I'm really going to try to do a shorter video. So let's start off the proof. The function whose derivative we want to find is f of x equals to cosecant of x. So the derivative of this function, which is f prime of x, is equal to the limit when h approaches 0 of, and remember the definition of derivative. It's the limit when h approaches 0 of f of x plus h minus f of x over h. In our case, f of x is cosecant of x. So this is f prime of x is the limit when h approaches 0 of the cosecant of x plus h minus the cosecant of x divided by h. And this is equal to the limit when h approaches 0. And then remember that the cosecant of x is 1 over sine of x. It's the reciprocal of the sine. So this is 1 over sine of x plus h minus 1 over sine of x divided by h. All of this divided by h. This is equal to the limit when h approaches 0. And now we're going to do the least common factor between sine of x plus h and sine of x. So this is h times sine of x plus h sine of x. And in the numerator, we are going to have sine of x minus sine of x plus h. Very similar to what we did in the previous videos. And in case you don't understand one of the steps I do, watch the previous videos, because as I said, I did the same steps, very similar steps, but in more detail. And so moving on with the proof. This is the limit when h approaches 0. And now we are going to remember an equation used to factorize trigonometric functions or expressions. So it says that sine of A minus sine of B, this is equal to 2 times the cosine of A plus B over 2 times the sine of A minus B over 2. So we're going to apply this equation here. So in this case, A is equal to x and B is equal to x plus h. So this is the limit, as I said, limit when h approaches 0 of 2 times cosine. As I said, A is x and B is x plus h. So cosine of x plus h over 2. So doing it quicker here, x plus h over 2. This is 2x plus h over 2, which is equal to x plus h over 2. So cosine of x plus h over 2, then sine of, now we have the opposites, a minus b. So in this case, b is negative on the sign. So a minus b is going to be x minus x plus h, and all of this divided by 2. So this is x minus h over 2. X and minus x cancel out, and then we have h over 2. So this is sine of h over 2, and we have all of this divided by h times sine of x plus h times sine of x. this is equal to, before we go on to the next step, we can have a little bit of mathematical manipulation here, so things get a little bit easier. So, oh, and I forgot about a sign here. There is a negative sign here, so a negative sign here. And then we can remember the sine of x is an odd function, which means that sine of negative x is equal to negative sine of x. So this negative sign can kind of get out of the sign, come right here, and then the sign can also get out of the limit, because it is like if a negative 1 was multiplying all of this. So we can have this negative sign out of the limit. Then we are going to multiply, we're going to divide both the numerator and the denominator by 2. So this 2 cancels out, and then we have here, we can put this 2 dividing the h. It's going to be useful in the next step. So yeah, let's move on to the next step. This is equal to negative, this negative sign here, limit when h approaches 0 of. And now what we're going to do, we're going to use a property of limits that says that the limit of the product is equal to the product of the limits. So we're going to split this limit into two other limits. So this is going to be limit h equals 0, and here sine of h over 2 divided by h over 2 times the limit when h approaches 0, and then the limit of what's left here. So we have already used the sine and this h over 2. So we are left with cosine of x plus h over 2 divided by sine of x plus h times sine of x. This limit is very similar to the fundamental trigonometric limit, which is 1. So this is 1. You can say, oh, this h should be divided by 2. But when h approaches 2, when h over 2 approaches 0, h also approaches 0. So this limit is 1. And only the limit, this negative sign, is out of the limit. So we have negative sign here. And this limit, when h approaches 0, this whole thing here approaches cosine of x over sine squared of x. And this is equal to negative cotangent of x times cosecant of x. So this is the derivative of the cosecant of x. dx of, I wrote cosec, let me just use CSC of x. So here, CSC of x, cosecant of x. This is true if you didn't see it. Cosine over sine is cotangent. And then there is another sign here, so 1 over sine, and this is cosecant. So this is the proof of the derivative of the cosecant of x. Thank you very much for watching, and I'll see you in the next video.